Okay, today's topic is probability, a very easy topic. That's because we have problems based only on single events. You will study this topic again in standard 12th at middle level and then in BSc and engineering in great detail. This has got wide applications in military warfare, genetics engineering, physics, financial engineering, extensive applications. In fact, you will find several volumes of books exclusively on probability. Like you have an introduction to probability theory by William Feller, volume 1 and 2. Then a first course on probability theory by Sheldon Ross. Please do not buy these books because we are not covering even 1% of what is there. Okay. Fine, now let's come to the point. Probability means what is a chance of something happening. So we are trying to quantify. Like what is a chance it will rain tomorrow? Okay. What is a chance that you will win in a casino, in a gambling game? So these are based on probability, and it is so designed that any person winning in a casino, the probability is very, very, very less. Okay. Now, let's take a small example before we formally solve the sums. Just take a card and write A on it. Then we have B on it, C, again A. Both the A's are the same. And then we have D. These cards are thoroughly shuffled. We just say out of sheer common sense, which alphabet has got a better chance of coming? Naturally A, because there are two A's. So chance of A coming is more. Now that does not mean that you shuffle the cards and you pick up the first card itself has to be A, no. But it has got a better chance of coming because there are two A's. So wherever you put your hand, the chance of A coming is more. So we say probability of A coming, probability of A. How many A's are there? 2. 1, 2, 3, 4, 5. Total possibilities 5. So probability of A coming will be 2 by 5. 2/5 chance. So this is an informal way of solving. Okay. So 2 A's hai. So chance is 2 upon the total. So 2 by 5. So now from this, what do we say? How can we define probability? Probability will be number of favorable outcomes. Number of favorable outcomes. Favorable outcomes means what we want. Divided by total number of possible outcomes. So probability is defined as number of favorable outcomes divided by total number of possible outcomes. And probability is based on the theory that it is always between 0 and 1. 0 and 1 both inclusive. So let there be some event, something happening. So we will have this kind of a relation. Probability of E of any event happening is greater than or equal to 0 but lesser than or equal to 1. So 0 and 1 both inclusive. If probability of some event is 0, then that is known as an impossible event. If probability of any event is 1, then that event is a sure event. Like say for example, there are 20 red marbles in a bag. Okay, now you just pick up one marble at random. What is the chance it is red? Naturally 20 red marbles are there, so 20 upon 20, that is 1. It is sure event, it is bound to happen. But if I say there are 20 red marbles in a bag, one marble is picked up at random, what is the chance, what is the probability that it is a yellow marble? That's not possible. So it is an impossible event. The probability will be 0. So remember, probability is always between 0 and 1, and probability is defined as number of favorable outcomes divided by total number of possible outcomes. Always give the answer for probability in the simplest fraction form. So if you get something like 10 by 18, 10 by 18, then it will be written as 5 by 9 and not 10 by 18. Formula needs to be written only once, because normally what happens is a probability sum may have 3 subparts or 2 subparts. So formula to be written for any one subpart. And favorable outcomes always have to be shown for every step. We will understand as we do the sums. So are you clear on the rough idea of what probability is? This question normally comes in section A, one question on probability for 3 to 4 marks. So now let us see the sum. Question 1. In a single throw of a die, find the probability of a number greater than 4, less than or equal to 4, not greater than 4. Let's analyze. In a single throw of a die, you might have played Ludo. So what you have a die, it has got numbers from 1 to 6. Find the probability of getting a number. So you just take a die, put it, and find the probability of the number on the uppermost surface of the number being greater than 4. Okay. To get probability, we need two things. One is favorable outcomes. That is what we want. And second is possible outcomes. All the things what can happen for that particular experiment. Now greater than 4, we want the probability of a number. What we are doing is theoretical probability. Okay, now theoretical probability and experimental probability will practically give the same answer if the number of trials are very large. But nevertheless, we are studying theoretical probability. Okay. Find the probability of getting a number greater than 4. So first we will write favorable outcomes. That is what we want. We want a number greater than 4. So what will it be? 5, 6. Why not 7? Because when you throw a die, what are all the possible things that can happen? You can get number 1 on the uppermost surface. You can get number 2, 3, 4, 5 or 6. So we will have to write our sample space. Now as I solve the sums, I am introducing you to certain terms, technical terms. Sample space is nothing but a collection of all possible outcomes. So favorable outcomes are 5, 6. Possible outcomes. In fact, possible outcomes need to be written first. Possible outcomes will be 1, 2, 3, 4, 5, 6. It is not really necessary to write in brace brackets and all. In 12th standard, yes, you have to write in brace bracket and the set notation. But here if you just simply list it down, it is good enough. So possible outcomes kya ho sakte hain? You can get 1 or you can get 2 or 3 or 4 or 5 or 6. They said we want the probability of a number greater than 4. So favorable outcomes, what we want, will be only 5 and 6. So now probability will be number of favorable outcomes divided by total number of possible outcomes. So that formula you will have to write and show the substitution. So favorable outcomes are how many? 2. Do not confuse between favorable outcomes and number of favorable outcomes. Favorable outcomes are 5, 6. But how many such favorable outcomes are there? 2. So probability will be 2 by 6, that is 1 by 3, and we will be leaving it as it is. Second subpart, probability of getting a number less than or equal to 4. Now see, the sample space will remain the same. there is no change. So no need to write the sample space again. But yes, if the sample space changes in certain cases, you will have to write it again. But here the sample space is going to remain the same. We want the probability of a number less than or equal to 4. So less than or equal to 4 means 4 can come. 3, 2, 1. These will be our favorable outcomes. It is very necessary to write favorable outcomes for every step, else you are bound to lose 1 mark. But sometimes it is very difficult to write favorable outcomes, especially in the card sums or in certain cases where there are too many numbers to be written. In such case, it is okay if you write number of favorable outcomes. At least that if you write, it is fine. But wherever possible, always try to list down the favorable outcomes for each and every subpart, because favorable outcomes will keep on changing. Now, probability of this happening. How many favorable outcomes are there? 4. What were the possible total number of possible outcomes? 6. So probability is number of favorable outcomes upon total number of possible outcomes. So 4 by 6. Remember to put it in the simplest form, that is 2 by 3. And no need to repeat this statement again, because we have put here subpart 2. So it is sufficient if you write P, it stands for this only. So you should have the idea how to present it crisply. Else then you find the papers lengthy, because you are drastically over presenting. Probability of a number not greater than 4. Not greater than 4. So 5 and 6 cannot come. Okay. But 4 can come. Some of you may feel 4 will not come. See, read the language carefully. Not greater than 4. Not beyond 4. Okay, so 4 can come. So favorable outcomes will be 4, 3, 2, 1. Again, these are what? Favorable outcomes. So probability will be 4 by 6, that is 2 by 3. So this completes your first sum. Question 2. If 2 coins are tossed once, what is the probability of getting blah blah blah? Now remember, 2 coins are tossed once. They are tossed simultaneously. This can also be reframed as 1 coin is tossed twice. So note that 2 coins tossed once or 1 coin tossed twice will give the same sample space. If 1 coin is tossed once, no problem. You will have head or tail. These are the possibilities. But if 1 coin is tossed twice, or if 2 coins are tossed simultaneously once, the sample space will remain the same. So first let us see the sample space. That is all possible outcomes. Now see, when you are tossing 2 coins simultaneously, just visualize this situation. You can have head on the first and head on the second coin. You can have head on the first, tail on the second. You can have tail on the first, head on the second, and you can have tail on the first and tail on the second. So this is one entity, one gattha. So head on the first, head on the first. That is one combination. HT, second combination. TH, third combination. TT, fourth combination. So this will be our sample space. So just take this down, because I will be erasing this now. No, okay, let it remain. It will be easy for us to refer. what is the probability of getting 2 heads? So to find probability, what do we require? Favorable outcomes and total possible outcomes. Total possible outcomes are done. Now we require favorable outcomes. So subpart 1, you require 2 heads. So what can I choose from this? HH. So favorable outcome. Favorable outcome will be HH. So probability will be number of favorable outcomes upon total number of possible outcomes. So how many favorable outcomes are there? HH. HH is a single gatha, it's a single entity. So probability will be 1 because HH is the only possibility. And what are the total number of possibilities? 1, 2, 3, 4. This is to be taken as a single gatha, single entity. Don't consider this as 1, 2, 3, 4, 5, 6, 7, 8. No. So this will be 1 upon 4. So probability is number of favorable outcomes upon total number of possible outcomes. So this will be 1 by 4. It can be further simplified. No, leave it like this. Second, but this favorable outcome we will have to show for every step. Sample space we write in the beginning because it remains the same for all. In case the sample space changes, you will have to write the sample space also. At least one head. At least one head. Translate into your mother tongue, you may understand better. At least one head. कम से कम एक head तो चाहिए. उससे जास्ती भी चलेगा. So at least one head means minimum one head तो we require. More than that is also fine. So can we have HH as our favorable outcome? Yes, because they want at least one head. And this is having 2. So good. So favorable outcomes will be HH. Can we take HT? Yes, because it has one head. Is at least one. Means one or more. So HT will very much come. Can we have TH? Yes. Can we have TT? No, this is not possible because they need at least one head. This doesn't contain even one head. So now probability will be number of favorable outcomes. Mind you, these are our favorable outcomes. To get the probability, we require number of favorable outcomes. So number of favorable outcomes, 3. Total number of possible outcomes, how many? That too we know from beginning, 4. So probability will be 3 by 4. Find the probability of getting at most one head. At most one head. That means maximum one head. Lesser than that is also not a problem. At most. Note the difference between at least and at most. If I say at least 5, suppose at least 5 means 5 or more. If I say at most 5, that means 5 or less. And this is at most one head, maximum one head. So favorable outcomes. Will HH come? No, because this is containing 2. They want maximum one head. So this is ruled out. HT is possible because it contains one head, at most one. TH is also possible and TT also will be possible because see what they said, at most one head. That means less than one head is also okay. ज़्यादा से ज़्यादा एक head, उससे कम भी चलेगा. Less than one head means what? 0 heads. 0 heads means what? Both tails. So TT will also come in our favorable outcomes. Now it is fine. Probability will be 3 by 4 because there are 3 favorable outcomes and total possible outcomes are 4. So probability will be 3 by 4. The final subpart, both heads or both tails, is a flexible operator. Both should be heads or both should be tails. We are okay, no problem. So favorable outcomes, both heads. So HH or both tails. So TT. So probability of this thing happening will be 2 by 4, that is 1 by 2 in the simplified form. So this completes your question 2. Question 3. Cards marked with numbers 1, 2, 3, 4 dot 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 up to 20. These are not playing cards, simple cards like pieces of paper. So cards marked with numbers 1, 2, 3, 4 up to 20 are well shuffled and a card is drawn at random. What is the probability that the number on the card is a prime number? Now here we cannot write all possible outcomes 1, 2, 3, 4, 5, 6, 7. So what we can write, and even if we wish to write, we can write 1, 2, 3, 4 dot 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 20. No need to list down all 20. That's quite a big number. So what we can do, we can write number of possible outcomes. Number of possible outcomes. We are not listing the possible outcomes. This is just the final number of possible outcomes. That is 20. Now one card is drawn at random. Find the probability that it is a prime number. So here we have to definitely list down the favorable outcomes. 1 is not a prime number. 2 is a prime number. 2 is the only number which is even and prime. So this is 2, 3, 5, 7, 9 is not prime, 11, 13, 17, 19. You know what are prime numbers. Okay. So favorable outcomes are these. We will have to definitely list them down. It is not sufficient if you just give the final number. We will have to actually list it down. So let me verify 2, 3, 5, 7, 11, 13, 17, 19. Now we want to find the probability of a prime number coming up. So what is probability? Number of favorable outcomes upon total number of possible outcomes. So how many favorable outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So probability will be 8 upon, and what were the total possible outcomes? 20. So 8 upon 20, which we have to put it in the simplified fraction form, and formula to be written only once for any one of the 3 subparts. So write the formula in the first subpart itself. But for others, you will have to naturally show the substitution. So probability is 8 by 20, that is 2 upon 5. So now subpart 1 is done. 2 and 3 are remaining. Probability of a number divisible by 3. So 3, 6, 9, 12, 15, 18. These will be what? Our favorable outcomes. This is what we want. Now what is the probability of this happening? 1, 2, 3, 4, 5, 6. 6 by 20. So that is, again, remember to put it in the simplified form, 3 by 10. Now the final subpart. So this is also done. A perfect square So favorable outcomes, we'll have to definitely list it down. So 1 is a perfect square. Never write like this. It will be mistaken for -1. Just write favorable outcomes are over. 1 is a perfect square, 4 is a perfect square, 9 and 16. So what is the probability? 1, 2, 3, 4. 4 by 20. 1 by 5. This completes your question 3. Question 4. A box contains some black balls and 30 white balls. If the probability of drawing a black ball is 2/5 of that of a white ball, find the number of black balls in the box. So there are some black balls. So X black and 30 white. So altogether how many balls? X plus 30. They are telling you probability of drawing a black ball. So we will write P of black is 2/5 of that of a white ball. That means 2/5 of the probability of the white ball. So 2/5 of the probability of white. So probability of black ball. So how many black balls are there? X. How many total? X plus 30. So it is like number of favorable outcomes upon total number of possible outcomes. This is equaling 2/5 of probability of white ball. How many white balls are there? 30. Divided by total how many? X plus 30. Now this X plus 30 and X plus 30 will get cancelled because X plus 30, since X plus 30 cannot be 0. The reason is if X plus 30 is 0, then X will be minus 30. How can the number of balls be negative? So when I am cancelling this, I have to ensure that this quantity does not have the potential to become 0. Then only we can cancel it. So now we are left with this. So it will be X is equaling 12. Now just because we have found X doesn't mean that the sum is over. We will have to see. The question says find the number of black balls in the box. Okay. So there are 12 black balls. No need to write the final statement because we have written here X black and X is 12. The same sum could be modified. Find the total number of balls in the box. So then you will have to go one step ahead and say 30 plus 12, 42. 42 would be the total number of balls in the box. But here they have asked you only number of black balls. So black balls were X. So and X has worked out to be 12. This is done with your question 4. We are just one sum away from completing this topic. Before we go to our final question, which was going to be on playing cards, I feel it is necessary to have a quick recap of the theory of the cards. 52 playing cards, joker is not included. Cards follow symmetry, half red, half black. So 52 playing cards are divided as 26 red cards, 26 black, no other color. Now which are the red cards? So you'll have 13 of hearts. This is called one suit, S-U-I-T. 13 of diamonds. So you'll have hearts and diamonds red. Then 13 cards you'll have of spade and 13 of clubs. So this is called spades. This will be clubs. This will be hearts and this will be diamonds. It will be best if you buy a pack of playing cards and then connect this theory. It will help you to visualize and get a clear picture, and you will get clear bifurcation as to what cards are okay. Some are here, some are here. If you have never seen playing cards, then this may go difficult. So I suggest you buy a pack of playing cards, because sums in the board exam do come on this. It, in fact, once it has come also. Okay. And then you correlate. Now, so 52 playing cards, 26 red, 26 black. There are 4 suits, 4 categories. So hearts, diamonds, spades and clubs. Spades and clubs will always be black, and hearts and diamonds will always be red. Now the inner bifurcation, ace, the highest honor card. Ace is also known as a honor card. You cannot call it as number 1 card. There is no number 1 put on ace. Ace is not a numbered card. Ace is an honor card, the other name. So there are 4. So you will have 1 ace of hearts, 1 ace of diamonds, 1 ace of clubs, 1 ace of spades and 1 ace of clubs. Now we have face cards. Face cards are also known as picture cards, because there's a picture on it. If you see Jack, Queen, King, they have the picture on it. So they call it as a face card or a picture card. So you'll have Jack, Queen, King. So you'll have Jack of hearts, Jack of diamonds, Jack of spades, Jack of clubs. Same applies for Queen and King. So how many these are? 3. And for each there are 4 types. So 3 into 4, that is 12. Numbered cards, they are 36 in number altogether. Let us see how. Numbered cards start from 2 and not from 1 in the pack of playing cards. So it is 2, 3, 4, 5, 6 up to 10 only. You cannot have your own numbering and say Jack, Queen, King will be 11, 12, 13. No, this is not a standard thing. So 2, 3, 4 up to 10. So how many cards are there? 9. 10 minus 2 plus 1. So 9 cards, and each one will have 4 types. So you'll have like 2 of hearts, 2 of diamonds, 2 of spades, 2 of clubs. Same applies for this, all other numbers. So 9 into 4, that is 36. So now 36 plus 12, 48, and ace were 4. 48 plus 4, 52. This was the theory. Now we will see the final question for this topic. Question 5 and the final question for this topic. From a pack of 52 playing cards, all cards whose numbers are multiples of 3 are removed. Now you have to be very careful whenever certain cards are removed. These sums are little tricky. So whose numbers are multiples of 3 are removed. A card is now drawn at random. What is the probability that the card drawn is a face card? Now here the sample size cannot be taken as 52, because what has happened is certain cards are removed. They are removed and we are now drawing a card from the remaining pack. So our sample size reduces. So all cards which are multiples of 3 are removed. So what will happen is 3, 6 and 9. Cards whose numbers are 3, 6 and 9, on which the numbers are marked, they are removed. But this does not mean that only 3 cards are removed, because when you remove a card of number 3, so you will have 3 of hearts, then you will have 3 of diamonds, 3 of clubs, 3 of spades. So what happens is, how many cards are removed? Now if number 3 card will have how many types? 4. 3 of hearts, 3 of diamonds, 3 of clubs, 3 of spades. So 3, 6, 9, 3 cards, each card 4 variety. So how many cards are removed? So number of cards removed will be 12, right? So 4 types are there in number 3, 4 types in 6, 4 types in 9. So altogether 12 cards are removed. So remaining will be 52 minus 12, that is 40. So now from this remaining 40, we are removing one card. So this was the calculation which I showed you. So here the sample size is not 52, it is 40. This you might have taken it down. Okay, now find the probability that it is a face card. Now mind you, certain cards are already removed. So 3, 6, 9 numbered cards are removed. Now removing of the numbered cards do not affect the face card. Face cards are still intact. How many face cards are there? 12. Now here we can't go on listing it down. So just write number of number of favorable outcomes. So in solution, just put subpart 1 and write the previous steps also need to be shown. So number of favorable outcomes. Here we are not writing the favorable outcomes. We are not listing them down. We are just writing number of favorable outcomes. They would be 12 because there are 12 face cards. Jack, Queen, King. Each one will have 4 varieties. So 12. So probability of getting a face card will be 12 upon 52. No, because 52 is not our sample size. Our sample size has now reduced to 40 as explained earlier. So probability will be 12 upon 40. Answer has to be given in the simplest fraction form. So 3 by 10. This part is now done. An even numbered red card. An even numbered red card. So let's first get the even numbers within our sample space. So it's like 2, 4, 6, 8 and 10. Not 12 because cards are numbered only up to 10 and they want even numbered. So 2, 4, 6, 8, 10. But mind you, as I told you before, whenever certain things are removed in the beginning, they may affect our outcome. Now here they said multiples of 3 are removed. So what will happen is 6 cannot come because it has already been removed in the very beginning. So now 2, 4, 6, 8, 10 is correct, but 6 cannot appear because multiples of 3 are already removed. So we are left with 2, 4, 8 and 10. How many cards? 4 cards. How many varieties in each? 4. So you'll have 2 of hearts, 2 of diamonds, 2 of clubs, 2 of spades. This way 4 cards are there and each variety 4. So 4 into 4, 16. But our number of favorable outcomes cannot be 16 because they said even numbered, which we took care of. Red card. This will give you total. And what did I explain in the beginning? Cards follow symmetry. Half red, half black. So 16 is fine. 16 cards will exist. But we want red. So out of 16, how many will be red now? 8. Because cards are always half. Exactly. So our answer would be 16 upon 2. That is 8. So probability of such a thing happening will be 8 upon 40. That is 1 upon 5. Now if they would not have said red card, just an even numbered card. Suppose if they would have just said an even numbered card, then our answer would be 16 upon 40. That is 4 upon 10. But they put in condition even numbered red card. So 16 was our answer, all possibilities of the cards what can exist as per the given condition. But then they want red card, so half, 8 black, 8 red. So our probability will be 8 upon 40, that is 1 by 5. Hope you enjoyed the topic. Thank you.